Hey guys, we are T-minus 2 weeks, less than that, into being completely done with Animal Science 1. If we look at the remote learning guide, we have today, we're going to be going over mitosis. It's going to be like a super brief lecture because it's exactly the same thing as mitosis, just done twice and a little bit differently. And we're going to go into Punnett squares. Next class, we're going to have a little bit of a discussion on heritability. And then y'all are going to have some SchoolNet questions. So 4 more class days. And y'all are going to be done with the Animal Science 1. So I'll go on ahead. I'll pull up the PowerPoint. So, like I said, today we're going to go over meiosis. I know mitosis was last week, so if you need to look at the presentation from last class, go for it. Relook through mitosis because the steps, interphase, prophase, metaphase, anaphase, all that is exactly the same. Move a little camera piece. The major difference between mitosis and meiosis is that, give me a second. Sorry, important text message. The major difference between mitosis and meiosis is that mitosis creates cells that are exactly the same, identical twins. The cell that's created is exactly the same as the cell that it came from. There is no genetic differences because it's using the exact same DNA. In meiosis, you're creating different cells. So the cells that are created, they're called daughter cells. So the daughter cells have different DNA in them as compared to the other cells. What meiosis does is it uses half the DNA from parent number 1 and then half the DNA from parent number 2, and they come together and the DNA mixes roughly 50-50 to create a new daughter cell. So this is what we are. We are half of our mother, we are half of our father. So this is a pretty good little illustration here that shows the cells breaking apart, the chromatids, which are half of the chromosomes. The chromatids breaking apart and then kind of crisscrossing here so that we've got this little red piece which should belong right here. It's actually over here. So it's not exactly the same. So that by the time you go through it all, you end up with no cell is completely alike. Gametes, if you remember from earlier in this unit, gametes are the sex cell. So the female gamete is the egg, and then the male gamete is the sperm. The egg and the sperm come together and they form a fetus, they form a baby. So one set of the chromosomes right up here comes from the sperm, comes from the male. And then one set of chromosomes comes from the ovum or the egg, meaning the female. When they come together, they form the zygote. The zygote is like the very first step in making and producing a baby. The zygote isn't yet the fetus. The zygote is the zygote for a couple of days until it gets just a little bit more formed, and then that's when we go from calling it a zygote to calling it a fetus. The zygote is created during fertilization, and it has chromosomes from each parent. So it's not an exact match from its mom, it's not an exact match from its dad. It's a combination, a roughly 50-50 combination of its mother and of its father. And that's because of meiosis. That's because in prophase, metaphase, anaphase, telophase, That's because when those chromosomes and those chromatids are moving around, you've got one set from one parent, one set from the other. They're not exactly the same. So when the DNA gets moving around, you're not going to get an exact copy of parent number 1 or parent number 2. You're going to get a mix of parent number 1 and parent number 2. So sex cell formation. So how is the sex cell made? So for males, the sex cell is the sperm. So how is the sperm made? How are the eggs made in the females? They're produced through meiosis. The production of sperm, so sperm being made, sperm being produced, is called spermatogenesis. So if you're religious in Christianity, the first book of the Bible, the Christian Bible, is Genesis. Meaning, I don't know if it actually means that, but I've always been told that Genesis means the beginning. It's the first book of the Bible. It's the very beginning of creation. So I always remember that the production of sperm is called spermatogenesis because Genesis in Christianity means the beginning. So the beginning of sperm. Male animals, they begin producing sperm at sexual maturity. And this gets a little bit technical, but the spermatocytes divide into the spermatids through meiosis. So basically the spermatocytes, we're going to say this red one right here is a spermatocyte. If both of them are spermatocytes, when they break apart, we get spermatids. In females, sex cell production, it's the egg. How is the animal producing eggs? Again, we have Genesis, meaning the beginning. And then the O's, always, in animal science at least, O's typically relate to ovulation, eggs, ovaries, something along the lines of female reproductive abilities. So oogenesis is the production of the ovum or of the eggs. When females hit sexual maturity, that's when they also begin producing eggs or producing ova. And the oocytes divide and they form ovum. The ovum contains cytoplasm and stores food. So cytoplasm, that should kind of like send off a light bulb, like, hey, I've heard that word before. Yes, you have. So you've heard cytoplasm when we learned about the parts of the cell. Cytoplasm is like the goo, the jelly that holds the cells all together. It keeps the nucleus here, it keeps the mitochondria there, it keeps the lysosome over here, it keeps everything in its place. So the ovum contains cytoplasm so that everything there stays in place. And it also stores a little bit of food so that when the zygote is formed and then it turns into the embryo, it has some kind of nutrient. Because at this point, when it's the zygote, it hasn't attached to the uterus. It's still just kind of floating around wherever it got fertilized. When it's important that it attaches to the uterus because it's a direct line of food. If it doesn't have a direct line of food, oh, there's a fire truck coming by. Fire truck. Actually driving around. The egg, or sorry, not the egg, but the zygote is just floating around in the uterus. Doesn't have anywhere to get food. It's like when you're driving in the middle of nowhere highway and you're hungry for a snack, but there's nothing around. That's kind of how the zygote is until it gets to the uterus where it can attach and the mother can share its food with it. So that's why it's important that the egg or the ovum has stored food in it so that the zygote still has some kind of nutrients until it can get attached. Hello, next slide. Okay. Oh, my computer is just Interesting. Well, we'll just try to close this out and we will see if we can reopen the PowerPoint. I'm surprised I made it this long without a PowerPoint malfunction, if we're gonna be honest. All right, we were somewhere near slide 100. You don't realize how many slides we end up going through until you look at the review guide and we're like, oh, we're on slide 25, slide 50, slide 75, so on and so forth. Nope, a little too far. Okay, so we just finished that slide. So I'll move myself all the way off the screen. So these are the actual steps in meiosis: interphase, prophase, metaphase, anaphase, telophase. But if you look over here, you see we've got these little I's. They're actually Roman numerals, meaning 1. Prophase number 1, metaphase number 1, anaphase number 1, prophase number 2, metaphase number 2, anaphase number 2. This is what this is meiosis is essentially mitosis done twice. And it's done with different DNA. So here we've got our DNA. We've got our little centrosomes that are end up going to forming spindle fibers. In prophase, it's exactly the same as mitosis. What happens in prophase? The DNA clumps together and it forms chromosomes. It's no longer just this crazy ball of DNA. It forms little chromosomes. In metaphase, meta meaning middle. In metaphase, what happens is the spindle fibers, we can see that they formed from the centrosomes, and they've got chromatids lined up in the middle. Anaphase, they're being pulled apart. So if you look right here, you can see we've got a purple chromosome that's got a little bit of blue in it, and then we've got a blue chromosome with a little bit of purple in it. This means that the DNA has worked on crossing over. So they've kind of exchanged some DNA. I'm going to take this bit here, you're going to take that bit there, so that they're no longer their exact copies that we see up here. They're completely different from the mother and the father. So anaphase, they're being pulled apart to their separate sides. In telophase, the cell is working on splitting. And then in cytokinesis is normally kind of clumped together. Oh, excuse me, I got hiccups. Cytokinesis is normally clumped together with telophase, because in cytokinesis, if you remember, that's when the cells fully split apart and the rest of their little organelles start forming. But normally, so this is where mitosis ends. Mitosis says, I'm done. I've got 2 exact copies right here of the parent. Meiosis says, I have 2 different cells and we're not done. So it ends up moving up here and we restart. We've got prophase 2, metaphase 2, anaphase 2, so on and so forth. So we can see our DNA, it's a little bit mixed up, but it's still mostly itself. So by the end of this, it should be about 50-50 split up. Right here, it looks about 75-25, 75 original, 25 new material. So that's why it says, hey, we're not done. Gotta get to 50-50. So metaphase 2, same thing happens, or prophase, same thing happens. Guess I should back up a little bit. The DNA clumps together. It forms chromosomes. It's not this spinny, jumbled clump of DNA. It forms chromosomes in prophase 1 and in prophase 2. In metaphase 2, meta meaning middle, they line up in the middle. The centrioles or centrosomes form the spindle fibers to work on grabbing it. Lined up in the middle. Anaphase, they're pulled apart. Telophase, they're working on splitting up. So that what you end up with is this. You get 4 granddaughter cells. These are the daughter cells, the first generation. The mother and the father came together. They had daughters. When the daughters have children, granddaughters. So meiosis produces granddaughter cells. And it produces 4 of them. And all 4 of them are completely different than the daughters and the mother and father. Ooh. So, like I said, if we were in school, we would be doing all these fun stuff. We would be eating Oreos. Don't get to do that this year. It's unfortunate, I know. And then we would play some cell division bingo. However, can't really do that either. So what you guys are gonna do, you got 15 questions. You're just gonna go through, match them up with the term and the definition, and you're gonna be all good. So let me know how things go. We've got less than 2 weeks of class left. I'm really excited for you guys. Hop on Zoom if y'all have any questions, if you just wanna hang out. Tuesday, Thursday, 1 o'clock as best as I can to stick to that schedule. Last week that didn't really work out. I'm sorry. But let me know what I can do to help you guys. See y'all.